Okay, guys, it's good to see you once again. I think we can start. The other guys will join us because I think the content we have is substantially a lot. Hi, Rose.
Hello.
Good to have you.
Thank you.
Edgar, Gidi, Slim, Daudi. Daudi ameingia na amepotea. Karibuni sana. So I'm thinking as the others join, we can just start, and since this is being recorded, we'll guys can play the video and see where they had missed out. So this is just a follow through to what we agreed a while back, where we agreed that every Wednesday is going to be NLP, apart from last week when we were doing a recap. We did the recap Wednesday, Thursday, and Friday. So starting today, it's going to be NLP. One thing I must say is the NLP we've not covered in class, and the guys who've covered beginner and intermediate are at an advantageous position because there's some concepts that would help understand. But I'm going to try as much as possible to bring down and explain it without assuming anyone has attended any classification or regression class before. So I need you guys to confirm if you can see the slide that I'm going to share right about now.
Yeah, I can see it.
Perfect. So I think we can start right away. Using Zoom at times it's difficult. You have to do it a couple of times before you get it right. I'm trying to set up my screen so that I don't have issues. There are guys waiting. Okay, great. So this session is dedicated for NLP. NLP is just natural language processing. And it's the first of many classes, and I won't assume anything. And as usual, I'm not the teacher or I'm not the lecturer. I'm just facilitating this session. I'll just tell you some concepts. I know in this class there are guys who are ground zero, and there are guys who are a bit advanced. So for the guys who are a bit advanced, I would request for your patience. And for the guys who are on ground zero, don't worry. Feel free and ask any questions. The guys who are advanced might chip in where they know. I'll definitely make sure that your question is answered and to your satisfaction, and then we can follow through because there's only much we can cover in 2 hours. So don't worry if your question or concern is not answered satisfactorily. We'll definitely have subsequent sessions. So feel free, let it be engaging, and don't let the 2 hours be of waste. And what I mean by that is make sure that the concept being discussed or being brought up are relatively understood by yourself. Or if you don't understand, ask questions. So by the end of the session, at least, ask a question so that by the end of the session, at least you'll have learned something new, or at least you'll have explained something. And by you explaining, you'll even grasp it much better. That's what I encourage those guys who are in advanced, not to keep quiet and to participate actively in this session. Okay. Natural language processing. The way I would like us to approach this is not to look at it like this. It's something weird out of the moon. As guys, we speak on a daily basis. The only thing I'm using right now to speak to you guys is English. because that is a common language. Another common language is Kiswahili, yeah? But in our native language, I don't know how many people are either Kikuyu or Luo, but we can't use that as it is right now because we are a mix of people from different regions and with different ethnic background. So unless if I speak Luo or Kikuyu, I get a translator so that the students can get to understand what I'm trying to say. So the language that you're speaking, then let's speak on English, for instance. English has certain, we definitely learned. We went to school and we were taught English, and there are certain rules governing construction of English, pronunciation of English, and whether you know it or not, maybe in your native language, there are some rules also governing how you construct sentences, how you make pronunciation. You get. So all these things. The main point here is through the language that we use, we are communicating. Yeah, like right now, I'm facilitating a meetup where we are teaching ourselves natural language processing. And I will say some concepts, and the students or the other guys will also articulate some concepts. So through that, we are communicating. And the language of choice is English. Yeah. So we will focus on English, and what happens is there is a way English is formed, and there are certain rules that actually govern how it is used to communicate. So there isn't nothing weird about that because we normally speak every single day with our babies, with our parents, with our teachers, with our lecturers. We speak every single day. However, the reason why NLP is a bit of interest is, can we have machines understand and communicate the way us guys we are communicating right now? So even before I delve into how machines can understand what we talk about, I would like us to put this into context before we get a bit techy. The things that we listen to on a daily basis, or we come across once in a while as we Google, there are some terminologies that are basically common. And one of them is sentiment analysis. This is one area that NLP is widely applicable. We have chatbot, we have speech recognition, machine translation. Sentiment analysis is just a way of determining should I use sentiment? Determining which word? Rose, help me out. Which word? I don't want to use the same word to describe it. What's the synonym of sentiment? The feeling.
Sorry.
Rose, welcome to my class. I always pick people randomly to participate. So what I had asked is, what is the synonym for sentiment? I want to explain sentiment analysis, but I don't want to use the word sentiment in describing what it is. So help me out. If I don't want to use sentiment, how can I define or describe it?
I can say by either, it's like you're trying to group a statement as either positive or negative, or into maybe 3 groups, like positive, neutral, and negative, just to communicate. I don't know how to explain sentiment without sentiment.
Yeah, so we
But
are
it's
together.
something.
Yeah, I think you're absolutely right. I've seen on chat someone amefungua roho feeling huyu jamaa inakaa ana microphone, but it's okay. Chat is also acceptable. It's acceptable, and that brings us to a chatbot. So for those people without microphone, they can actually type and talk to a machine. In this case, I'm not a machine. There's this thing called chatbot. Gidi is saying sentiment can also be described as a feeling, which is very, very true. It's another word for sentiment. So you're just gauging how is someone feeling about either a certain topic or about a certain service? If it's within the context of customer service, how was I served? Am I happy about how I was served? Am I sad, or I'm just there? I got sorted and I really don't care anymore. So that is one area that NLP can be used to actually make such prediction, because there are predictions without the customer explicitly telling you that they are happy. You can actually gauge that they are happy from either the words they say, or maybe the way they choose specific words in their sentences. Are they ironical? Are they straightforward? So this is an interesting piece, and it's all falls into NLP. Chatbot is another example where, based on certain questions, a machine can actually get to answer your questions. So you're having a conversation with a machine, and the machine has been trained through NLP techniques to be able to understand what you're saying and give the most appropriate response. And in advanced cases, the machine can also be trained that should the machine feels like the answer it's about to give is not appropriate, it can actually escalate that message to a human being. And when the chatbot actually escalates a message to a human being, what it does, it takes note that, okay, I have no idea what this guy is asking me, but let me ask for help. And the moment the human being gives an answer, the chatbot actually gets to learn from it. So as the answers are being, as the questions are being answered by the human being, the chatbot gets to learn. So the next time you ask a similar question, the chatbot will be able to respond accordingly. Another one is speech recognition. We have authentication systems like now, let me say if you had a safe in the bank and you're asked to, au VIP, unajua most of us hatujafika huko, lakini kuna wanyama wako sawa. Kuna wale wakiingia kwa bank, you're told, okay, yes sir, come, you have an office over here. So if you're there, like Gidi, you'll be open for a certain private room, and you'll be served some tea, and you'll be welcomed to your safe. And your safe, you can decide, you can open it using your, you can decide to open it using your fingerprint, using your eyes, or even speech. And the speech could be something like open my account or open Sesame. And then the safe, the doors to the safe is open, and then you do your biashara. Kama ulificha hapo hivyo some LR documents for corrupt deals, unaweza fungua uendelee nayo. Kama ulificha hapo bunduki, it's your own business. But basically, you can actually use speech to authenticate you to certain services, even accessing certain buildings, yeah? And then machine translation, I think this one is very, very common. We all Google, and maybe there are some answers that Google normally replies, and you end up in a website written in Chinese. Google can actually help you translate that Chinese from Chinese to English, being developers, yeah? So NLP is a very, very wide field, and it's like it plays a key role in the AI space, because it tries to mimic a natural way of serving people. Long are the days where you sit down and fill forms. Can those forms be transformed into a chat conversation? Can you actually do a pre-screening interview with HR using a chatbot, and then the HR filters and selects based on the answers provided? So that is the direction we are going to, a very, very interesting space. And for all these things to happen, we have two things, yeah? The first thing is to enable the machine understand what you're saying. And there's quite a lot of activities in that space. And then the second part is, will the machine, how does machine respond to you? So if we think of the machine to be a child, how do we teach a child to understand that, oops, daddy is mad, or mommy is mad, or don't do that, or if you do that, it's going to be wrong? And how do we enable the child now to respond back? Yeah, you smack a child, they cry. You might tell a child a certain age, and then they can speak back to you. Maybe kids nowadays above 11, they actually have objective arguments with their parents. Yeah. So you think you can actually force something on your child, and they tell you some statements, unabaki tu umenyamaza. So splitting it, let's look at it like it is input and output. So whenever you're receiving those words, it could be speech, it could be text, you're giving the machine. How does the machine construct this and gives you a response? So that is, by and large, NLP in a nutshell. And that is what you're seeing in the screen. Yeah. So with natural language understanding, which is more often than not, it is much more complex and more involving than natural language generation. Yeah. So we'll cover quite a lot of stuff in natural language understanding, and get to see the techniques and approaches. Yeah. But basically, it's getting that text. In this case, I'm going to refine I'm going to create the domain of our discussion to be text. Yeah. So we want to look at text and get to be able to interpret them in a manner that the machine can understand, and ultimately the machine can give us a response. Yes. Now, we have several ways, or rather, we have normally, even as human beings, as we communicate, you might ask yourself, okay, what exactly did you mean? Yeah. So if in our own languages, whether it is native language, whether it is our slang, or whether it is for the millennials like Rose, whether it is English, whether it's Swa, there is some words, or whenever they appear in different sentences, they mean different things. And there are some words, whenever they appear on the same sentence in different way, they mean something different. So we normally seek for clarity. Those things and those instances are normally called ambiguity. And in NLP, if we really want to mimic the way human beings communicate, we cannot do that without considering the ambiguity that exists within our own languages. So there should be a way of minimizing the ambiguity, or better yet, eradicating the ambiguity. So it's a wide stage. So the number of ambiguities, there are more, but largely we have three types: lexical ambiguity, syntactic ambiguity, and referential ambiguity. So I'll just go and mention one of them. For example, she's looking for a match. The fisherman went to the bank. So if the fisherman has a bank account, and if the fisherman is going to fish, there is ambiguity. You'd ask, okay, what exactly do you mean? The fisherman went to the bank to withdraw, or the fisherman went to the bank to, to fish. So that is one level of ambiguity. Yeah. So one word used in different sentences meaning different things, the same word. That is lexical ambiguity. Now, let's look at the second example. With this COVID manenos, visiting a relative, or you can say that now you're in the house, it can be boring. Now, let's look at the second statement. Visiting relatives can be boring. Does it mean it's the event of visiting relatives that is boring? Or does it mean that you have relatives that when you visit, they're just boring? Yeah. So that is syntactic ambiguity. So the same sentence can mean different things. Yeah. Okay. Referential ambiguity. The boy told his father about the theft. He was very upset. So he was very upset. Was it in reference to the father, or was it in reference to the boy? Yeah, so that is referential ambiguity. So these are some of the challenges that in natural conversation exist. And one thing about machine learning, we are trying to mimic or enable the machine to behave just like human beings. So if there is ambiguity in our normal conversation or communication, then when we are modeling, we need to be cognizant of those ambiguity and try and figure out ways in which either to reduce the ambiguity or to address them. There comes some of the techniques that help us to do that. We have parts of speech. Now, every language, especially now in English, there is a way, certain order, words come after the others, they mean different. So you're studying English. So when you read a sentence, there's a way there are certain words, whenever they appear in your sentence, they help you construct meaning out of that sentence. Now, these parts are what would help the machine get to understand about the ambiguities and even able to infer what exactly we mean by what is said, either through text or through speech. And there are quite a number of parts. I'll just give an example. There are quite a number of tags. They are called parts of speech tagging. So each and every word in a sentence has a tag. Yeah, I know the most common one are nouns, verbs, adjectives, pronouns. Yeah, prepositions. There are quite a number. So it's good for you now. If you got A in English, then you're safe. If you were struggling like me, you need to now go back to Google and try and figure out what are all these things? What are these adverbs, adjectives? What do they mean? It will help you get an understanding of how parts of speech tagging works. It's not a must because the machine does most of these things, as you will see in the practical class. But for your own understanding, it is good to have an out of ML view of the meaning of each of these tagging, each of these tags. Let's take, for example, the dog killed the bat. There is a determinant, there is a noun, there is a verb, there is another determinant and a noun. Yeah, the waiter cleared the plates from the table. Yeah, so what I'm trying to say is every sentence, there is a way you can tag it so that it has the defined tags. So, and these tags can be understood by a machine. So when the machine is looking at interpreting what the sentence could be, or interpreting what the person is trying to communicate, it makes reference to the tagging. And even when once you tag, there are some other processes because the machine cannot understand text. There are processes after preparing that now converts what you have prepared, as we will walk through, into a language that the machine can understand. So for now, just understand that every sentence has certain tags, and these tags are important in understanding or extracting the meaning out of a sentence. Yeah, and it applies both to human beings. Yeah, human beings and machine as well. So if it is important for a human being to understand the parts of speech when talking, then it of course important for a machine to have the same understanding. For instance, I can't say that I'm going to sleep yesterday. It is wrong. Grammatically, it is just wrong. And we cannot have that conversation because there's a way someone needs to make that sentence. So, like I said, if you got A in English, you're safe. If you are struggling like myself, you need to read more. And these are some of the things I read every single day. I'm still trying to understand what a verb is, but anyway, I'm at least better than yesterday. So every single day you get to understand this stuff. Now, this is how it works. I've given examples of ambiguities, and the very, very basic, silly example is time is flying. Yeah, this is very, very common, very, very common. You can imagine if there was no way of trying to make the computer understand. Sorry, you see, Exactly. What I've just said. Making the computer understanding. Yeah, we're talking about learning English. Yeah. Anyway, that's besides the point. Now, if we did not have a way of making the computer understand that time is flying is more of a metaphor than it is in real life, then we'll have scenarios where you have a clock that is flying like an insect. You get? And if you look at all these instances, yeah, they have different tagging. They look at the first one, yeah, time with the clock is flying, time flies like an arrow. And look at the tagging for the second one, and look at the tagging for the third one. Yeah, depending on the way sentences are constructed using English. Yeah, so that was just an illustration of how the tagging is important on any text. Okay, we have several techniques to do this tagging. Yeah, I've mentioned lexical based. We have lexical ambiguities, and these are lexical based methods of addressing such ambiguities, where it checks the most frequently occurring word in the corpus. A corpus is just basically, look at it like a reference of several documents, or a reference of several statements, or a reference of several sentences. So how many times does a tag appear in all these sentences, for example? Yeah, and then the machine will be able to use that to make certain decisions. So we also have rule-based methods. Yeah, so you define a set of rules when you're doing your tagging, and the process make references to these rules before making a decision. Probabilistic and stochastic method, these are based on probability of either a tag appearing in a sentence, and also considering other words around it, like other words that came before it. So most reference is now being able to make or even to predict the next word in a sentence. I think we've all experienced this, where you're typing an email and Google autocompletes, even in your phone, autocompletion. That is just, what are the chances that you're going to say good evening? So you start with good, and then Google gives you good evening. Or when you're replying to an email, you say dear, Google tells you sir, madam, and then you just select. So these are some of the applications. And when you're doing that, there are two different types. We will, in subsequent sessions, we will definitely go through and understand more about these methods. This is the introduction. I'm just giving you an overview, but definitely in subsequent classes, we'll dwell much more in each of these, and you'll have some grasp of how to implement them and how to use them using Python. And the last one is deep learning methods. We have ways of, we have deep learning methods like either using a recurrent neural network. So basically you're building a network that would be able to do these predictions. It does everything for you. And that's why I said natural language understanding is a bit more difficult than natural language generation, because using a recurrent neural network or something called LSTM, you can actually build a network and do prediction of the next probable word the customer is going to say in a sentence. Yeah, so we'll delve much into this. This is just a mention, and yeah, I've mentioned there is rule-based, there is stochastic, and neural. Neural is more of in deep learning. Yeah. We will also have, I think, sessions talking about hidden Markov method. Those are some really deep stuff. So I'm just mentioning them. If you get your chance, If you've come across them, you can actually add something in this meeting. If you've not come across them, then just have an open mind. At your own time, Google and find out what was Ayub talking about, and that would really help you understand subsequent classes. All right, and natural language generation. Now, this is where the computer has, you've trained the computer to understand what the text is meaning. Now you want the computer to respond back. There are several techniques. One of them I've already mentioned, using deep learning techniques. There are others that you can actually use. Retrieval methods, like now based on certain templates. You just the machine actually uses certain templates to give back the response. Yeah. And several methods, I hinted on some. Markov chain, most predominantly used in predicting the next word. Recurrent neural network, LSTM, these are neural networks that are trained to do more or less the same thing. Transformer is very latest technology. It's an attention modeling done by Google. We will, in subsequent classes, we'll look at each of these in more depth. All right, before I go to terminologies, labda kuna watu washatoka hata hii meeting. I'm just talking to myself. Any question? Any question?
I have a question. I have a question.
Yes, yes, go ahead. That's Sharon.
Yeah, that's Sharon.
Okay.
Go back to before the the rules, the techniques, the tagging techniques. There was an example you showed us.
Where? Here.
Yeah, no, go
Before.
no after that one. Time
Okay,
flies.
here.
The
Template.
one time flies.
Okay.
Yeah. What's the difference between these three sentences? Because you can see that they've been tagged differently, and it's basically the same sentence.
It's
the use of different techniques.
it's the different techniques of tagging. It's a different techniques of tagging. This is an illustration of based on the technique that you choose, it will have an implication of the understanding of the sentence.
So the different techniques, they give different tags for the same sentence.
No. If I understand you, you're asking if different techniques giving different tags for the same sentence. Is that what you're asking? I'm trying to understand your question.
Okay, my question is, this is the same sentence.
Yes.
In the three instances.
Yes.
But I can see that they've been tagged differently.
Yes.
So I was just asking, is this the use of different techniques?
No.
Okay, because they can't understand, as in it's the same sentence, it's supposed to be the same tag.
This one is, yes, I am getting what you're saying. I'm getting your question, by the way. It's the same way I explained about ambiguity. Yeah. When you make the understanding to the ambiguity that is in the sentence, it will make you understand it better. So one sentence can have different interpretation. You get?
Yeah, I get it.
So depending on the interpretation of the sentence, someone can either look at flies to be a verb or like to be a verb.
Okay.
Yeah.
I get it.
Yeah. It's strange enough. There was someone else who had a question. Anyone else with a question?
Oh, Ayub.
Yes?
Oh, I just wanted like to explain to her the differences of the sentences, but you have already tackled it, so it's okay.
Oh, okay, okay. All right. Where were we? Yeah. So when you're doing NLP, we have quite a number of terminologies that are good to get the gist and hang of it, even before you start coding. And we get an understanding of how the machine would eventually split a whole document into, maybe say, a whole paragraph into sentences, from a sentences to word, from now word to vectors, and then from vectors to modeling. So there is a way that the machine does all this stuff to understand the meaning and the intent in the sentence that it's been given. The first one is normally tokenization. So basically, it looks at the sentence and splits it into individual words, and each of those individual words is called a token. There's really nothing more than that. It just splits that sentence into individual words, ready to start now the processing. Yeah. And then as it breaks them down, there are several ways within which it can regroup them. You know, it's funny, it's splitting them into tokens, and then you, as maybe the engineer behind it, you can decide you want to do some correlations using the available techniques, and you want to split those words into sets of either 2 or 3 or whatever number you want. So those sets, if you have sets of 2, it means it's a bigram. If you have sets of 3, it's a trigram. And if you have sets of whatever, it could be 4, 5, that is an n-gram. So these are terms that you need to be familiar with, because when you're doing analysis of either the predicted words and you want to look at the combination with the most effect to your prediction, you might want to split using one of the techniques to view which are the top 3 combinations that actually contribute to this prediction. If it is text classification, for instance, that is a classification problem. So you might want to split them into bigram, trigrams, and n-grams. That is another terminology that you need to be aware of. And another key terminology is stemming. Basically, stemming, wale watu wanapanda miraa. It's not the stemming that I'm talking about. It is stemming, looking for the root form of a word. So let's look at the examples below. Affectation, affects, affections, affected, affection, affecting. I'm going to throw it to you guys. What is the root of all these words? Haya, mkinyamaza pia mimi nitanyamaza tu. Anyone with an answer?
Affect.
Sorry?
Affect.
Yes, it's affect. That is the correct one. Daudi, sauti ilienda wapi? Okay. So you're correct. It's affect. So basically, that is what it does. It just refine it to the root word. However, stemming has a disadvantage, depending on the stemmer that you use. So basically, when you come to implementing, there are several stemmers that are available in Python, and depending on the stemmer that you use, there are some that are very aggressive, and in situations like let me say give, giving, gave, you might find that it refines it so harshly that, for instance, using this example, affect, it might write affect without the T, or a good example is give without the E. So there is another one. You have to be, there is another one called lemmatization, and it also does more or less the same thing, but what the difference is, it ensures that the root word is actually a proper word. Unlike stemming, where the root word could be anything. It could be even a word that does not exist, like GIV. GIV is not a word that exists in a dictionary, but based on stemming, if you are to stem give, gave, giving, gave, depending on the stemmer that you use, you might end up with a word like GIV. Yeah. So depending on the problem statement that you're using, you need to be aware of when to use stemming, and if you're using stemming, which one to use, and when to use lemmatization. All these activities, we are still on natural language understanding. We are trying to understand what is the syntax, what are some of the key syntax of this language, or what are some of the patterns we can derive out of from this language. There is something else that normally help us make meaning out of a sentence, but in real world, they add no meaning completely. It just helps us make a sentence with a meaning. So these are words that the machine does not need. Yeah, and when you look at past of speech tagger, things like determinants, words like they, he, she, we, all these words, they only assist in deriving meaning out of the sentence. But the machine, they don't add any additional value in the sentence. Yeah. So such things you need when you're building an NLP model, especially either it's a classification problem, you need to drop the stop words before you start, even way before you convert it to a language the machine can understand. Yeah. So that is another concept that you need to be aware of. And another one is named entity recognition. Now, entity recognition, I would want to pause there and leave it to someone to try and say what this could mean. Name entity recognition within the context of text analysis. Okay. The silence is loud. Wacha niende kwa Mwakenya. Yeah, the first person, too bad. Carol, your name comes first. Do you want to give it a shot?
You will tell me whether I have an idea or not.
Sure.
But from what I get from the word entity is like something that groups several components into one.
Mm-hmm.
So maybe it will like sort of bring together and try to see how they relate. If they do relate, then it's maybe termed as a single entity.
Mm-hmm. Mm-hmm. Okay.
And then now it's recognized. Now maybe we subject it to now what we are saying NLP.
Okay.
Yeah.
Okay. All right. Someone else with a different opinion? Dan? Dan, do you want to give it a shot?
Am I check?
Sorry?
I think it's what Carol said.
Okay.
Trying to identify an entity. Could group the items
Mm-hmm.
to discrete groups.
Okay. Okay. Daudi? It looks like Daudi preferred way of communication is chat. Let's see what he has said. Recognize entities of a sentence within the context of a sentence. Okay, so I'm just going to rephrase what you guys have said using an example. So, for instance, let's look at a situation where we go and we pull one message from Facebook, from any Facebook fan or any Facebook user. And the message goes like, I'm looking for a 3-bedroom house in Langata and my budget is 20,000 shillings. If you are to extract meaning from that sentence, I am looking for a 3-bedroom house in Langata and my budget is 20,000 shillings. Yeah. To extract meaning out of that, you will first find out what is the intent, location, what is the budget, and what kind of house are they looking for. So an entity is probably something like the location, and budget is another entity that you might want to extract. Basically, from that sentence, extract it and store it somewhere. So name entity recognition is identifying these important entities from within your sentence, and it will help you to derive some meaning out of what the intention of that message is. Yeah. So I'll give an example. Is that statement from Facebook, for instance. I think using that example is pretty clear, and I think it echoes what you guys have said. So that is more about named entity recognition. I don't think I need to add any more. If we proceed to, yeah, exactly. The next slide is another example. Google CEO Sundar Pichai introduced the new Pixel at Minnesota Roy Center event. Yeah. So the location is an entity. Sundar Pichai is the name of a person, and Google is an organization. Yeah. So, and all this, extracting this, as a guide, you can still make reference to your parts of speech tagging. Yeah. Because a name of a person, is it a noun? Is it a verb? Is it an adjective? I'll pick people. I'll pick people. I might get volunteers. Sling. Haya, Sling.
Rudia swali.
Okay, nimepata mtu alikuwa analala, ndio huyo tu. So I'll repeat, yeah. So the question was, Sundar Pichai. It's a name of a person. Is it a noun? Is it a verb? Is it an adjective? Because I wanted, I was making reference that named entity recognition. You can also make reference to the parts of speech tagging to help you identify some of these entities from your text.
I'll go with a noun.
Okay.
Yes.
Okay. All right. So definitely you can use parts of speech tagging to help you extract some of these entities. But as in subsequent classes, I will be as we will be implementing these things in using Python, you will see there are libraries that actually you can train models that helps you extract these entities automatically. There are so many. Yeah. Okay, and the next term is chunking. Now this I'll push it to Rose. Rose, what do you think? What do you understand by chunking? It's an open book question. Anyone can answer. I just picked on Rose.
I would say it's picking up of pieces of information.
Sorry, just repeat.
Ayub,
Yes?
let me try.
Shoot, go ahead.
I think it's now breaking down pieces of information into smaller sections. Yes, something of the sort. So you have something big that now you're breaking it down into smaller sections. So that
Yes.
maybe you can just tackle them.
Absolutely. That is it. So you group certain words together. You're splitting it. It's a process or to help you process your sentence further. So depending on your objective, you split it into, just like you said, into sections, and the sections could have one or more parts of speech. Okay, mpaka hapo before tuanze kuangalia code. Do we have any questions? Yes?
Yes, on the chunks, are we breaking them down into smaller pieces or are we group them to form a larger piece?
Okay, it depends on where you're, actually it's grouping them to form a larger piece with slightly more meaning.
Okay.
Yeah, because if we started with tokenization, remember tokenization was the first one.
Yeah.
So when you split them, we caught the Black Panther. These are how many tokens? 1, 2, 3, 4, 5. So chunking is now adding this 1, 2, 3 into one set, and then this one, and then this one, depending on how the objective. So you're right.
Okay.
Ayub, just
Yes.
a question.
Yes.
I've arrived a little bit late, but probably you could tell me what the abbreviation means.
Okay, this is a proper noun. What you're talking about is parts of speech tagging. This is a proper noun, a verb, a determinant, adjective, and a noun. Yeah. So, so part of what we've covered, let me show you. Let me just go back to the slide where we discussed this. Yeah. So you see, what you're trying to understand in a normal conversation between human beings and using a specific language, there are certain instances where we experience some ambiguity. And these are some of the things that when you're modeling an NLP problem, especially for text classification or even chatbots, when we are building a chatbot, these ambiguities need to be addressed in one way or another, so that the intent, like now to derive meaning and the prediction that needs to be made is understood by the machine. So the ambiguity is largely addressed by understanding how a sentence is formed. And a sentence is formed through some rules governing a specific language, and in this case, English. And in English, you have adjective, the way the sentence is being constructed. So I would call it grammar. And there is a way you can be grammatically wrong. So what we are seeing in this slide, let me just show you. This is an example. This is another example. The dog killed the cat, where we have determinant, noun, verb, determinant, noun. These are examples. So what you're looking at here, excuse me. What you're looking at here is now, after doing tokenization, you can decide in your Python code to like now break it into chunks as a way of building the what is called it's part of doing a text analysis. There is a way you can use Python to build a tree and try and understand more how the sentence is constructed for your own inference. So that is what the grouping. Initially, they were split using tokenization, and now you're grouping them to make into subsets. That is what is happening here, and it's called chunking. Eric, are we together?
Yeah, got it.
Yeah, okay. Was there someone else who had a question?
So what does NP stand for?
This is a proper noun.
NP.
NP, it's a proper noun, or let me just make reference, just give me a minute. An NP proper noun. And some of these tags, they differ depending on, yeah, Sharon.
Yes.
That is a proper noun.
Okay, so it's NP or NNP.
Yeah. So some of these tags, they differ depending on, I think, the tag set. Tag set is a class, and these are libraries available in either in NLTK or Stanford NLP. There are several, and you in some instances you'll find a reference to NP and NNP, like in this case. Are we together?
Yes.
We are together, Sharon.
Yes, we're together.
Okay. Rose.
Yes.
I was checking. Come on, Baduko. Okay. We've covered that. We've covered that. We're in chunking. Any other question before? Okay, what I'm going to do in the next set of slides is just to go through specific code and highlight some of the areas that you're going to cover in subsequent classes. Like I said, there are several ways of approaching NLP. And some are by building normal classifiers. I think almost everyone in today's class understands what a classifier is. So there are some, we are going to use normal classifiers, standard classifiers, and there are some approach you're going to use neural networks, RNN or LSTMs. Yeah. So the subsequent slides for today is going to focus on building a basic classifier. So next Wednesday, we're going to start the coding, and I'm going to explain each of the concepts that we have covered. And as normal, share the notebooks. So before I start on the slides, anyone with a question on NLP?
I don't, but as a reminder, do send the notebooks in form of notebook, not PDF.
Okay. Okay. Felista?
I'm good.
You're good, huh?
I'm just following.
Oh, that's good. I noticed you are struggling to join in a while back. I hope you join on time.
Oh, yeah.
Okay. Okay. Moses?
Yeah, thanks, Robert. I am on point.
On point, huh?
Yes, I'm on point. I'm really learning a lot.
Okay.
Yeah. Combining assembly language and business intelligence. I can see all these things here.
Okay.
Yes.
All right.
Thank you.
Edgar?
Yeah, I'm following. I'm okay. Actually, I'm okay.
You're okay. All right.
Yeah.
I know guys are waiting for Jupyter Notebooks. Jupyter Notebooks tunaanza next week Wednesday. But whatever we've covered today, as usual, you need to go through them and read and ask questions and do your own research, and so that the next class is even much easier, and you can actually contribute. So it's more of engaging. The more you engage and contribute on what you've understood, it sticks. So I'm hoping next week Wednesday, you guys will be correcting me where nawadanganya. Then I'll throw one or two things off. I want to hear someone correct me. And the same thing. That is the main objective. Mimi siwafunzi. Mimi na facilitate too. So I think that is the best way of learning. You just get a tip, you go and paddle in the mud, ask questions, and then teach your neighbor. That should be the model. Okay. Sasa kama hakuna swali lingine, what you're looking at is a function within Python. And before we get to the Python, this is the advisory I would give. Okay. Kuna mtu ako kwa ndege?
Daudi. Daudi.
I've muted him. Kwani David is in the plane? Ama what is going on? Hapana, Daudi, I think you go back to your preferred choice of communication. Just chat.
We understand.
Daudi, where to my text? Sorry, man. I thought you were in a plane. That noise was just too much. I was almost asking you drop some dollars.
I actually thought it was my mic.
Yeah, okay. Now, thank goodness that is done. So what I was saying,
Daudi says he has a question, but has...
Oops, sorry.
I was saying he says he has a question, but he hasn't asked.
Okay. My question is, if POS tags would charge for sentence that carries sarcasm in it, how will it work? Okay. This is a very, very good question, by the way. Metaphors, sarcasm, I think it would be a combination of techniques for you to be able to detect sarcasm. It's not just a matter of POS tagging. It's a combination of techniques. And depending on the approach or model you build, there are some techniques that can actually pick that up. And there is one that I had mentioned. It's attention modeling. It's by Google, a very, very recent technique. 2017, transformer based. Let me just go back to that slide. If you do your model with this, where was it? No. Yeah, here. A transformer based. So it has a set of encoders and decoders. The best approach to be able to pick sarcasm and and metaphors and such stuff in your sentence is to use deep learning techniques, and attention modeling is optimal, a very good example, or even an LSTM. Rose, I would like to bring you on this discussion. You guys did a certain model. What did you come across such situation in your analysis?
Repeat the situation, sorry.
Sarcasm in statements. How do you pick sarcasm in text?
For that, we placed that under future scope. We did not tackle it because we did not know how to maneuver through it. Yeah.
All right. So, Devi, because you cannot speak, I believe you can listen. I think it's a combination of techniques. POS tagging is not enough for you to pick this, unless now you're doing some serious coding, and that would be too much work. Why don't you just use one of the deep learning techniques to be able to pick this up? That would be my response. I don't know if there is anyone else with input to this. Anyone who's experienced this before, or they've read about it, or they've implemented it? Okay. So we might want to simulate that in future classes, and actually so that we can see how it picks it. And I think everyone will appreciate to see how sarcasm and metaphors are picked by some of these techniques. So I'll take it upon and see that in future classes we can actually illustrate that, so that you appreciate some of these techniques. All right? I think, David, that will be good enough. So in subsequent classes, we will be able to illustrate that. All right. We were in coding. Now, there was an advisory I wanted to give. Yeah. Considering this is a new field, and it's a field that requires a lot of work in terms of programming, in terms of understanding the concept, in terms of, there's so much you need to do as an ML engineer, and you get lost on where to start. And one of the key things, or the key questions I always get is, I don't know programming. Must I learn programming? And the answer to that is yes, you need to learn programming, but the approach you take is what I normally differ. Most people normally take the approach of trying to learn, get a Python book and start from ground up. That will take you longer, especially if you're in the workplace and you're under pressure to deliver a certain task or a certain project. Trying to download all these books and tutorials will only waste you time and put you in a depression space, because there will be a lot of demand. So the approach I would want to recommend you guys, first thing, try and ask yourself, what do I want to achieve? So if it is a basic thing, like now, I just want to be able to echo my name in a browser. As simple as that. How do I do that? So I go open Notepad and write HTML code, and I echo my name. And then I see my name, it's very tiny. How do I increase the font? And then I research, and then I find out how to increase the font. And then I ask myself, how then do I make it beautiful? It's just black. I need to give it color because I'm a happy person. I need, when I'm talking about my name, I have color. How do I add color? So that is the approach I want to recommend each and every person. If you don't know any concept, don't sweat. Don't sweat. Just understand the concept and try and figure out what is this one thing that I need to learn how to do. And then go and find out how you need to do it using the preferred language of your choice. Once you do that, if you're pushed into a time crazy line of, say, a week for you to do something, you will have trained yourself on how to pick the most important thing you need to learn, because you don't have all the time to learn. You need to learn something in the morning, and in the evening you've implemented it. Yeah? So in this case, within the same context, we need to clean this message. Considering what we've covered, what we have covered in theory. We've covered a lot of terminology, stemming, lemmatization, removing stop words. So after learning this, you ask yourself, how do I achieve all this and get what the machine wants? And that is what we call cleaning. So this function that I put here, it's a function that combines some or almost all the important elements in cleaning your text. And it uses a certain library called RE. RE is a regex. So before Wednesday next week, explore RE and try and understand what it does. So my assumption is when you came to this class, is say, for instance, you did not know programming and you're wondering, how do I start learning programming? My advice would be, the first programming you need to learn is understand how RE works. So if you took the approach of starting from hello world and you want to be a machine learning engineer, it will take you for long. It will take you a much longer path by the time you come to building a model. But if you use the approach I'm proposing, the moment you understand what goes on when doing cleaning, you are a step closer to building a model with zero experience in programming. So the assignment that I'll ask you guys, especially if you've not programmed anything in Python, just go spend between today and Wednesday next week, read about regex expression, RE expressions. So we will implement it in Python, and an understanding of that, you will see it in action in Jupyter Notebook. Okay. Having said that, I want us to walk through this function step by step, just highlighting some important concepts. So the first one is the library. There is a natural language toolkit library. It's a Python library. Stanford NLP has its own. So this library helps you do most of the things, actually all of the things that we've mentioned: stemming, lemmatization, converting text to lowercase, tokenizing, all those. So you need this library. So once you do it, through using the library for RE, which is regex, you can start looking at the text that you pass. So this cleaning text, it takes the parameter for a message, yeah? And then there is a library called Beautiful Soap. So I've told you, read about RE and take some time and read about Beautiful Soap. So Beautiful Soap, you pass message, a text, it could be a sentence in it, and then it passes, especially when your text has potential HTML content. So you can use Beautiful Soap to only extract text. So it drops every other thing. For example, if it had images, if it had HTML words, those are things that you don't need. So once you get the text only, this is the text that you want to make some replacements, yeah? So the first line, you're only taking words, yeah? The second line, you're replacing special characters. The third line, you're replacing a plus, minus. The fourth line, you're replacing carriage return with nothing. Fourth line, new line. The fifth line, the same apostrophe on the sixth line, and single quotes on the sixth line, and double quotes on the third line. So basically, these are things that are helping you to replace what you don't need in a simple manner. You can imagine if you are to filter through and write code to change this, it would be longer than what you're seeing. Okay. So number 3, this one, we are removing email. We don't need anything email. But if you are analyzing text from Twitter, for instance, or if you're analyzing text from, you want to build an email bot, so that when someone sends an email, it passes through the content and replies automatically. So you might want to use this and you clean it. But since we are using, we are just interested in text, we don't care about email and stuff, we remove them. Okay. And the same things I've explained. You might want to convert all your uppercase, or all your text to lowercase, and then here you tokenize it, and then here you identify stop words. Yeah. So you're going to use stop words library for English. So someone would ask, do you have stop word library for Swahili? Okay, there is a lot of work and a lot of research work to construct equivalent toolkit for Swahili. And it's basically a corpus. So there are some corpus that are for different languages, and you could actually use it. In this case, you're going to use English. So the moment you go, you start looking at additional corpuses, you're now getting into advanced NLP techniques. Yeah. So this is a function that will loop through and remove the stop words, and then you do your stemming. There is snowball stemmer, there is portal stemmer. There are quite a number. So depending on the stemming that you choose, you need to be careful, as I had mentioned earlier. Yeah. Okay. And then the last one. Now, out of all this processing stores now the clean sentence in the variable called words. And this function here, it now returns that words. Excuse me. So that is what is happening. That is what is happening in this function. It's a very, very crucial one. And the first thing you need to do in NLP, amongst the first things that you need to do is cleaning. Any question on that? Okay. I'll assume.
Before you continue.
Yes, Sharon.
There was a term I came across. It's called bag of words. So the words that are returned, that's the bag of words.
No, we are going to cover bag of words. What we are doing here is what is returned is exactly the word that you had sent, but excluding what you don't want. So for example, if I had sent the little boy took the phone and sent money to the wrong number. So we have, as we had, we have tackled this previously on parts of speech tagger. Yeah. So the first thing you need to do before you process, you need to tokenize that sentence. You see, it's long. So once you tokenize it, there are additional tasks that you need to do. You need to remove, for instance, some words like, say, stop words that adds no value to the meaning of the sentence. For example, the word "the", that is a determinant. So you can write that, and using this function, stop words, you remove the word "the". So the output that comes out of this cleaning function will not have the word "the". It will not have any other thing that you don't want. If it had an apostrophe, the output will not have it. So you have a clean set of words that now you can take to the next phase. And in the next phase, I'll mention about bag of words.
Okay.
Yeah.
Thanks.
Maybe Robert, if I could ask a question.
Yes.
When you talk about cleaning of data, I thought it was removing inconsistencies and maybe incomplete or words, as opposed to what you've just mentioned.
Okay.
I don't know.
Yes,
just taking a
Moses, you're very right. It depends the problem that you're solving. In this case, you're working with text. This is now how you clean text. Now, in your context, you have a lot of data, and I think in the previous classes we mentioned about dependent variables and target variables. So if you have a data set in, say, Excel sheet, and you have some null values or some features you deem not important, and the way you're handling them, you can either choose to drop them, or so basically what I'm trying to say is, depending on the context and the problem you're solving, cleaning can vary. Cleaning of in NLP, this is the process you follow. Now, data processing and cleaning in classification problems, especially the one that we are, is not NLP, the one that you're using a data set or a data frame, the data that is in a data frame, then the cleaning will be exactly what you're saying.
Okay, thank you so much.
Okay, all right.
Ayub.
Yes?
on matters of the stemming area,
Yeah.
these different, is it libraries? What's the difference? Probably you mentioned, but I missed. Wasn't yet here.
Okay. There are some stemmers that are very, very aggressive. I give an example. If you take the various forms of the word give, it can have give, giving, gave, and which other one? Yeah, given. So if you use, for instance, a Potter stemmer, for example, and stem the word, all those words, you will find that it returns the word GIV. So you see, GIV is an non-existent word. It's not in the dictionary. Yeah, it's not in the dictionary. What is in the dictionary as the root of anything is give, G-I-V-E. Yeah. Now, when you're using a stemmer, you need to be aware of which one is so aggressive and which one is not. And if you are not so sure, then you'd rather use lemmatization. Lemmatization is it does more or less what a stemmer does, but it converts the output to a proper word. You will never, if you do a lemmatization on those 4 words that I've given you, you will never get the word GIV. You will get GIVE, because now the final word is a proper word. It's a word that actually exists. So that is the difference. So it's just a matter of knowing the aggressiveness of whatever stemming library that you use. Make sense?
Ayub, I have a question.
Shoot.
How do you expand abbreviations? Like some text you can find people have just used abbreviations. How do you work around that?
Oh, for someone has written shorthand. Okay.
Yeah, they're using some weird abbreviations.
Okay. I think it highly depends on the English corpus that you use. If there is a way of quote unquote auto-completing, but my guess would be such words would probably be dropped if you expose it immediately to an English corpus to check for stop words. Or the best way would be there's a way you can expose the same text to a spell check. So a spell check would most probably correct the abbreviations, yeah, and make it in full, and then you proceed and complete your analysis. Or you just treat it as normal and choose it as it is, and through certain techniques like count vectorization, those are techniques that we will learn later. It will look at it, you will still get the meaning even with the abbreviation. So it's again, I would want us to relate to the problem that you're solving, because we've faced instances where you analyze text and someone speaks in the millennials language, your XX something something, and the meaning is not lost because it was exposed to additional other sentences that the machine was able to pick. It is interesting. So for me, I've never come across where I personally have to either do a spell check before I move forward. But my guess is with or without correcting abbreviation, you can still meet your objective using machine learning. Personally, I've not addressed that problem that you're asking. Did you come across it?
I was just thinking of like the way you can check for miscommunication on Twitter tweets. Yeah, so some people are using like some weird abbreviations. Now I was wondering like how am I going to do this with NLP and stuff? So it's just something I was thinking of as you were talking about cleaning. Yeah.
All right. I think there are several ways. One would be before you start your analysis, try and do autocorrection. There are techniques of doing that through machine learning. And if that is too much, then you can ignore and do your analysis. Especially if it is text classification, that instance will relate to others, and depending on the number of times that abbreviation appears, it will either be dropped off or it will be related to others. So the meaning will still come out.
Okay.
Once you understand how subsequent processes work, then it will make much more sense.
Thank you.
All right. Okay. Any other question? Okay. Now, you've seen how in just using one function we can actually do a lot of cleaning for text and implement most of the things that we've spoken about. So another important thing that is normally done in NLP and any other modeling problem is visualization. The only difference is the visualization in NLP is slightly different. And the most common one is word cloud. So with word cloud, one thing that there is a way actually you can build this depending on your data. So word cloud looks at all your data and it tells you what that data is mainly talking about. Like just by looking at what I have projected, the conversation in the data was about property, real estate. You can imagine now if the text is smaller, then that conversation existed, but it was not as dominant as the ones that are bigger. That is what a word cloud does. So it gives you an overview of what the conversation is about in your data, depending on the analysis that you're doing. Okay. Someone is asking a question. Oh, okay, okay. Chris, definitely I'll share the function. That is Chris wanted to know the function for cleaning. Okay, that is word cloud. Another visualization that is important, just like checking the median mode of your data set when you're working with a data frame, it is important also to do the same, the frequency of words in your data set, and do a median and interpretation. So all this will give you some important insights on the average number, for example, the average number of words per sentence, yeah? And with your understanding, you can make certain decisions moving forward on the approach you take. If your sentences are pretty much longer, would a deep learning approach be more appropriate? Or if they are shorter, which technique? So depending on your preference, after understanding the composition of the average number of words in a sentence, you can make certain decisions. So visualizing this is important, and this needs to be in line with the average length of words in a sentence. Okay. You mentioned bag of words. Okay. So bag of words, I'm going to try. I wish I was in a class with a blackboard and a white chalk and a duster and a stick to cane kids who are not listening when I'm teaching. But that's not the case. I'm going to try very, very much to explain what bag of words is without the diagram and the chalk and all those things I mentioned.
Ayub.
Yes?
I think Zoom has a whiteboard.
Oh, it does?
Yeah.
Nice. Okay.
Yeah, you just have to stop sharing and share the whiteboard.
Yeah, yeah. So.
Oh, okay. Okay. All right. So let me see. Let me see if I can learn this quickly and project what I want to project. Whiteboard. I have to stop sharing.
Yeah, yeah. You just have to stop sharing, and then when you try to share screen, it will show you the you can choose the whiteboard.
Okay.
Yes.
All right. Okay. Let me do that. Ujinga imetoka. Let me try. I stop share. Then I share. Whiteboard, whiteboard, whiteboard. Oh, I've seen it. Bingo. Share. Can you guys see?
Yes, you can.
All right. So the first step was we did tokenization. Hey, boss, ni noma. Can I type?
Yeah, you should be able to type.
Text.
I think they're normally the
Oh yes.
options are normally up there.
Okay. There you go. So we've seen tokenization. And this one you're splitting. Grace, give me a sentence. Give me a sentence. I want to type it.
Zoom. Zoom has a whiteboard.
A whiteboard. Enrico, give me another sentence.
Daudi has problems with his mic.
Daudi has problems with his mic. Sharon, give me a sentence.
The weather today is bad.
The weather today is bad. Dan, give me a sentence.
The curfew starts at 7.
The curfew starts at 7.
Yeah.
Chris, nani sijamention hapa?
Daudi.
Daudi ataleta makelele ama atype.
I'm very
Daudi
happy.
type. Oh, Chris, sema yako.
I'm very tired and hungry.
I am very tired and hungry. Aya, hiyo ni ya mwisho because people are now tired and hungry. So let's wrap this up. Now, let's look at this, yeah? So, bag of words is, if we were to tokenize how many sentences? 1, 2, 3, 4, 5. If we were to tokenize all these 5 sentences, we will end up with 1, 2, 3, 4, 5. Okay, let's see. How many words here? 4. The number of words is 4. And the number of words here is 1, 2, 3, 4, 5, 6. Let's say 6. And then number of words here is 1, 2, 3, 4, 5. And then this one is starts at 7. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, 5. And then the last one is 1, 2, 3, 4, 5, 6. 6. So, wapi mathematicians? Total ya hii ni 26. Sindio?
Yes.
Total words 26. Okay, now I want total unique words. Total unique words. Okay, hapa kuna has, wacha tutoe hiyo. Tumetoa moja, 1, tumetoa. Any other duplicate? There, tumetoa 2. Any other? Sinizo. Unique words 24. So, if we were to arrange these unique words, as the columns. So if kuna Zoom, let's say we have Zoom as the first column, and then has as the second column, and then as the third column, whiteboard as the fourth. But you remember, we are doing some cleaning. We removed determinant, we removed words that do not add any meaning. And so I'm assuming a word like, oops, let me repeat that. excuse me. Zoom has a whiteboard. Yeah. So if we consider that we have not done the cleaning, yeah, we'll have Zoom has a whiteboard. And then the other words, the other 24 or the other 20 words are columns. These are piped through symbols to indicate it's a column. We are arranging them into columns. But if we do cleaning, stuff like are and has will disappear. So we would have Zoom, whiteboard. So what we end up with as our unique set of words is what is called a bag of words. Now the way it helps is I'm going to explain to you guys through something called count vectorizer. So count vectorizer, it looks at those bags of words and builds a sparse matrix. A sparse matrix is just a matrix that has the presence of a certain word or lack of. So if it has a certain word, then it has a one against that word. If it doesn't have a certain word, it has a zero. So when you're talking about the sparsity of a matrix, it means how many zeros does your sparse matrix have? So the objective is normally to reduce the sparsity of a matrix. Now, if we arrange this, assume that we have Zoom, whiteboard, Daudi, problems, weather, and we continue with our columns. Yeah, this becomes our columns. Let me take it to the next row. Zoom, whiteboard, this becomes our columns, and many more. So in the next, this becomes it. Man, okay, let me do this. If I rub, it's replacing the word. Let me bring Zoom there. And then we continue. So assuming that becomes the title of our, the headings of our columns, and then the rows of our matrix are going to be the index references of the sentences. So you remember, this one is the first sentence, this one is the second sentence, this one is the third sentence, and this one is the fourth and the fifth, yeah? So in the first sentence, do we have a whiteboard? The value will the value here will be a 1. And then, do we have Daudi in the first sentence? The value here will be a 0. Do we have problems? The value will be a 0. Do we have weather? The value here will be a 0. Do we have Zoom? The value here will be a 1. And then the next sentence, do we have whiteboard? The value here will be a 0. The value here will be a 1. The value here will be a 1. The value here will be weather, 0. So I think you guys are getting the gist. So this is a sparse matrix where we just want to look at the presence of the words that we had cleaned, the presence of the words that we had processed. Each of these words, are they present in any of those sentences which we are calling documents? So this one is equivalent to what? A document. So do we have presence of Daudi in the first document? Yeah. So basically, Sharon, I'm not so sure if the concept of bag of words is clear to you.
Yes, I'm getting it.
You're getting it. Now I'm
Yeah,
going to share. I'm now going to share the slide so that we can continue with we can continue with the slides. This one. This one. Right. Okay. So I've mentioned about the sparse matrix and count vectorizer. So basically, that is what we are doing here. We are creating a bag of words model, which is equivalent to what I've just mentioned as sparse matrix. And a sparse matrix is what I showed on the posts, on the wall, what is that thing called? What did you call it? Whiteboard, yes. Yeah, it's what I showed on the whiteboard. Yeah, so basically that is an action that we will be doing. Yeah, and you will come to understand why it is important for us guys to move that. You can now see the transition from, we are moving from text to vectors. Okay. Don't worry if all this looks really complex. We will cover this in subsequent classes, and we will actually open Jupyter notebooks and go through them. And then now, that is what we define as our feature set. That sparse matrix becomes our feature set. If you look at the columns and the rows and the values that you're getting, it resembles now our data frame that we use when we are importing Excel data into our Pandas data frame. So that is what we have done. And we put those features in our X variable. In our X variable. So here, this is our X variable. And now we have our features. Yeah. Now what we need to do is to define our target variable. So once we define our target variable using this command, we spoke about index location, how to use iloc to index locator, how to use iloc to pick some of these values from your data frame. And then the normal way as we do classification, we run our classifier against our prepared data, and when we generate our confusion matrix and do our predictions. It's not any complex. There are so many variations depending on the approach that you choose to take. If you choose to take deep learning, if you choose to take deep learning in terms of either you want to build a neural net or use a classifier. That is what will determine your actions that you take after defining your X and your Y. So in this case, because of the complexity and the variation of people in this class, I choose to follow through as first we do a normal classifier to classify the texts that to classify text using NLP. So that's the approach you're going to take. And our first model at the end of this exercise will have a classifier, but now an NLP classifier. After doing an NLP classifier, we'll look at using a neural net and other techniques. Iko swali. I can see Mercy has asked a question. How do we determine Y and X? Okay, it's actually good. It only means you're following through. I was let's look at a data set that has 2 columns, yeah? And given the explanation by Rose at the beginning, when trying to define what sentiment analysis is, let's say this data set has a statement, and on the second column, it has happy or sad. Yeah, it's either happy or sad. For happy, it is 1, or sad is 0. So we have an Excel sheet with 2 columns. So our target variable, which is our Y, then becomes the 1 or 0. Is it happy or sad? That becomes what we want to predict. So the X is the sentence. But because we are working with NLP, this sentence, we need to figure out a way of converting it to a vector. Yeah, converting it into a format that can be consumed by the algorithm. So, and the way that you convert that text into a way that it can be consumed by an algorithm is through the process that I've mentioned. First of all, you need to do cleaning, where you do your data prep, like removing stop words, removing unnecessary punctuations, stemming, lemmatization, you tokenize, all those things. Once you've done all those things within the context of NLP, then the next thing is you create a bag of words, which the output is a sparse matrix. And a sparse matrix has the indexes of the text sentences, as well as the features that you've derived. So the feature set is what now appears in the column, and the features is equivalent to the bag of words. And the sparse matrix is now the content. Now, if we covered encoding techniques previously, and there is some relation with encoding techniques. When you remember how we did our one-hot encoding, where a categorical variable is converted into ones and zeros, it's more or less the same thing we are doing with count vectorization. It's more or less the same thing. Yeah. So the understanding of one-hot encoding is the same understanding you need to bring when you're generating your bag of words, when you're generating your sparse matrix. So Mercy, I don't know if that makes sense to you. Oh, Mercy was only typing. Let's see if she has a response to that section. Where is the chat? Mercy, did I answer your question? Okay, so I'll assume
yes,
that.
you did.
All right, perfect. Okay, so I think this is a journey we're going to take. Today was just intro, so I'll try. Okay, I think we've covered most of the theory. So on Wednesday, we're going to walk through Notebook, and I think this is the last slide. Yeah, that is the last slide. So on the last slide, once you've done your modeling, you can do your confusion matrix and generate your classification reports, determine your accuracy, and then do your interpretation. Questions? And pretty much that is NLP. It's not difficult. Come on, we find a classifier. It's not difficult. You just need to understand the concepts, and the more you do this, the easier it gets. Any question? Okay. I know people are tired. Chris, are you still with me? You're tired and hungry. Sapa karibu imewekwa.
It was a statement, bana. Acha hizo.
Nakuanda.
I'm very much here trailing. Yeah, you know, pesi yangu ni ile ya kinyonga ile. Hapo hivyo tuna compete tu na Mose na Robin, but ni sawa.
It's okay. All right.
Some statements say the truth.
Yeah. The truth is, even me, I'm hungry. I don't know about you guys. I don't mean nasikia njaa. I think it's that time where we need to eat. But I'm
tired.
Yeah. I had asked in the group, guys, to think of where we can get data. But if I don't get the data by Wednesday, this is the approach we're going to take. Any person, anywhere, can just go to Facebook, collect any sentence that unaweza pata. Inaweza kuwa kwa comment, inaweza kuwa kwa post, pick it and put it in an Excel sheet, and please share. The more data we have, the better. So the objective would be, we get at least 1,000. Let me see, we are 15 guys on average. We are 15, actually 16 guys. So if each one of us does 100, we have 1,600. That will be substantial. That one will be more than enough for us guys to play around with, just to understand the concept. So the objective would be, based on the sentence, we are going to do labeling. Basically, we read that sentence and then we determine what label is appropriate for it. So the label in this case, we can add as many labels as we want, but the first label I would want us to to add is what is the topic. It could be the topic. It could be an industry, for example. Is this question for real estate? Is this question for banking? Is this question unrelated to anything? It's just a joke? Nimshene? Is this question about a company, shopping? So we just go fetching for each one of us 100 messages, 100 posts, and put it in an Excel sheet. Send that to me. I will create the Excel sheet and add the column for labeling. Once we label on Wednesday, we will run through our model notebook. If you've not installed notebook, install it. If you have problems, you have between today and Wednesday to get that done. And then on Wednesday, in 2 hours, we will try and at least cover 50% of what we've done. If possible, we do 100%, depending on now the typing and understanding of the concepts, but I don't want to rush it. Hakuna haraka. Bado tuko quarantine and lockdown. So that would be the objective. So if you can send me that Excel sheet, itakuwa poa sana. We will make steps. Me, I already have my 100 na nilitoa zote Facebook. So naongoja hizo 100 zingine nitumie kwa Excel sheet.
Niko nataka kuuliza Facebook peke yake.
Inaweza kwa Facebook, inaweza kwa Twitter, pale popote unaweza toa. Hata kama unaweza, you can think about it by yourself, you generate.
Okay.
Actually, the same thing you can't kuuliza kama tweets zinaweza kuwa sawa.
Hata tweets ziko sawa. And you're not limited to 100. You can put as many as you can.
Then I think with Twitter itakuwa simpler inaweza script it's like any amount of tweets tunahitaji.
Umeshaiandika nini scraper?
There's a certain script and I'll try and use
For
it
Twitter.
in Tatuma.
That would be perfect. That would be perfect. If you have that content, kama unaweza scrape, utasave so many people that effort. Just share the data. Alafu we get started on Wednesday. Inaweza kuwa about any comment.
I think niko na data.
Yeah.
On I did a nini for a different project. We did a tweet scrapping. I think I might still be having it.
Perfect. I think that would shorten our journey. If just go to the archives, ukiipata tuma, Dan hata ukipata tuma, I'll consolidate and then we will use that data set to further our learning.
All right.
Wait, okay. So it is just the comments, right?
Yeah, just comments. Any text, someone's talking about anything. We are not going to discriminate.
Okay, yeah, I have kinda that data and kinda scraper for that.
Perfect. Share that. And
okay.
When we come to the class for when we'll be using deep learning techniques, we will even require much more data. So the data we consolidate, the better. And whatever we do as a normal classifier is the same thing that we will try and do with deep learning techniques, and now compare and understand some of the techniques behind deep learning. So the more data we have on the onset, the better. Any question? So what we are getting is Dan, Eric, and Mercy. You guys will share the data that you have. Like the rest of you guys, amwepuki. We still want that 100. Tunajenga hii data set pamoja. Hakuna kuepuka.
Actually, watafute zingine juu hizi zingine ni specific on different topics.
Sawa.
I'm sure Mercy is on a project she did, yangu ni on a project we did, and we were searching a particular different.
Perfect. Sawa. Okay. All right. Any other question? Gidi, are you online? Ama Gidi alipoteza earphones.
Na Matthew?
Matthew?
Ama Ocha bado hakujapata stima?
By the Matthew hajakuwa leo, but anyway, tutawapata tu. There's a recording, they will follow through, no problem. Okay, so the last thing I would want to say is on Saturday, we are starting our classes, and this is the content that I'm preparing. For the intermediate one, I'm looking at two things, time series and a classification model. Time series is something we'd not covered in class, but I am so sure you guys have read it and tried it, so we will handle it as a class. And the reason why I'm revisiting classification, I want to bring in the concept of feature engineering and other concepts that we did not have, and in particularly so that we can be able to start on our projects. Sijasahau hizo projects. So we will run through the projects, and the first class itakuwa hiyo, and the timing itakuwa between 2:30 and 5. For the beginner, or sorry, not beginner, intermediate one, we will start from the normal schedule, because as guys, we had not made any advance. So you guys are lucky. We'll have intermediate from ground zero. So if you're in this meeting and you're wondering where to slot yourself in, you can join anywhere. Intermediate one will start from 9 to 12, I think, 9 to 12, intermediate one, and we will start from ground zero. And for intermediate two, it ends at 2:30, from 2:30 to 5. And that one will be very, very specific, time series and a classification problem. Kama kuna swali, I wish you guys all the best, and I think it was worth your 2 hours. I would like just to hear from you guys what you think about the 2 hours for today.
Before we recap, we give comments about today, I want to confirm something. We are in agreement that whatever is covered on Saturday, we will recap. But now the Wednesday we'll be doing NLP. I don't know how that will go. So for guys who miss Saturday classes for whatever reason, we agreed on recording, because now the recap will not be there as we are doing NLP.
Oh, okay. For Saturdays, the recording will be done, and yeah, it will be available to the students for Saturdays.
Okay.
Yeah. So if you don't make it, I highly encourage guys to make it for class, because it's not only the beauty of this session. It's not going to be one way. It's going to be discussion, and discussion is mimi nilienda nikasoma hii nikapata hii, mbona hii inasema hivi. You know, that is now the benefit of group study. I encourage you to be present, because you can listen to a recording, but you cannot participate in a recorded class. Okay. Chris, hiyo imeeleweka Chris? Iko sawa?
Imeeleweka. Najua nilikuwa ninataka kuchangia story ya recap, because naona ni kama hiyo imekunywa maji.
Recap tutaendelea tu. There is still so much content, mingi sana, but don't worry. I think if you don't miss the sessions, you stand to benefit a lot. So just follow the sessions.
Now the comment about today, it was awesome. It was worth my 2 hours. I bet I joined late, but because we are fresh, we have gathered some info from there. Maybe the sooner we get the recording for today, the better. So we stitch the gaps, we get to the whole concept. But I'm good. I'm good with it.
Okay, perfect. Edgar?
It's been awesome. We've gotten the point from the word go, and yeah.
All right. Okay.
You're moving well.
Okay. Caroline?
I'm okay. I'm flowing on well, and I would say it was worth my time. And I would request that you share the presentation.
All right. All right. Chris, umeshafungua roho, so tutakupita. Dan?
Yes, I think the sessions are okay. and it has been worth my 2 hours.
Okay, all right. Danson? Danson Maina? Okay. Gidi? Hao ni watu walipoteza earphones. It's okay, labda wanatafuta. Grace?
Yeah, it's been a nice session. I'm really looking forward to Saturday. Thank
All
you
right.
for that.
Okay. Okay. Who else?
I'm here
Mas?
now.
Oh, that's Danson. Danson.
Danson,
Fungua roho, fungua roho.
I'm following, but I came an hour later. But the session was awesome. Yeah, and NLP is interesting.
Ah, okay. All right.
Yeah.
Good stuff. Marcy?
The session was good. Just need to do a lot of reading on NLP, mostly the regress. Yeah.
All right. Okay. Mose?
Yeah, the session has been great. It is my first day, and so I'm trying to find my space. But I've really enjoyed the way it is delivered. I'm looking forward to the next classes. Niko chini ya utukufunzi.
Oh. Well, talk about NLP. Nafaa tutengeneze NLP ya Swahili. Hiyo imenipita. But it's all right. I'll decode that. Felista?
Okay, the session has been nice, and I'm really new to this, so I'm learning a lot.
Okay.
Yeah, at first nilikuwa na float, but at least niko somewhere.
Okay, that's
Yep.
good to hear. Robin?
The session has been good. I came in a bit late, but I caught up and just discovered I need to do a lot of reading just to be able to fill in the gaps that you don't get in class. But all said and done, yeah, I've enjoyed myself and I really appreciate. I'm looking forward to the days ahead. I bet it's going to be fun. Yeah.
Awesome. Awesome. And Rose?
Personally, the session was so good. I have learned some things that I'm going to apply now. I had just omitted some. Yeah, I think it was worth it. It was worth the 2 hours. Yeah.
Okay, awesome. Sharon?
The session has been great. It has been worth my 2 hours. At least I've gotten a better understanding of NLP, and I look forward to the next classes. Yeah.
Awesome. And I think I'm not leaving out someone. We have Sling.
All is well. Kuuliza tu if you can share the slide recording as early as possible. Kuna watu walikuwa dropped out in between.
Okay, now I'm going to share the recording immediately we end this meeting. So you'll get the recording and you can now review and take notes and play it at your own time. Awesome. Eriko ulifungua roho kweli? I saw Eric here.
No, mimi usaulika tu.
Aya, fungua roho.
Kufungua yangu kwanza, wewe uacha kunisahau. The session was good. I know as several people have said, I'll just reiterate like them. To join late, some of us, and we are hoping we'll be able to do some studying a little bit and watch the recording. Actually, nitataka kusikia sauti yangu kwa gaina sikikaje.
So I think that's it for today. I'm grateful for your attendance, and what I can encourage you guys is don't tire. if you really want to learn this stuff, the best way to learn is through a group and a meetup like this one, where you share what you've learned, and you also learn from others, and we be realistic, and we go outside our way and try and find out the best practices. And through such a meeting, we share, and whatever it is we'll finally come out with out of our sessions will be the cream. It will be the cream. We'll get there much faster than any other way of learning. So I want to encourage you guys to just stay with the sessions. You will definitely learn and benefit a lot. Having said that, you guys have a good night. And for those who are meeting on Saturdays, I'll share the Zoom meeting invites. It will be open. Join. And for those guys who are waiting for NLP next week, don't forget about what you need to do before then. And the people who are supposed to share the data, the earlier you share it with me, the better. Thank you guys, and have a good night.
Good night, you
Good night too. Good night.
Thank you. Good night.